Okay, in these two problems, I want to demonstrate something else for you, something you got to be careful with. It's not very common, but it happens sometimes. You just got to be aware of it. So we'll do this first equation here. I'm not going to explain everything. We're going to assume everybody already understands the process. So we got to distribute here. So we're going to have 8x plus 16 minus 14 equals, we got to distribute here. It's going to be 8x plus 2. We're just multiplying 2 times 4x. It's 2 times 4x plus 1, so it's 2 times 4x and 2 times 1. So here it's 8 times x plus 2, so I got to multiply 8 times everything inside. So we're going to now combine like terms on this side. I'm going to get 8x plus 2. If I combine these two terms, because they're on the same side already, 16 minus 14 is just 2, equals 8x plus 2. So when you notice this, 8x plus 2 equals 8x plus 2. We're supposed to solve for x. We're supposed to find the value of x such that 8 times x plus 2 equals 8 times x plus 2. What a lot of students are going to do here without recognizing that, they're going to say, okay, let me just get my x's on the same side. And watch what happens when you do that. In trying to eliminate this x term over here, moving it to this side or however you want to say it, you get 8x minus 8x on this side as well. 8x minus 8x, do not write x because 8x minus 8x is not x. 8x minus 8x is 0x. It's gone. The x's disappeared on this side as well. So the only thing left is 2 equals 2. If you keep going and writing everything down, the only thing left is 2 equals to 2. What this implies in the future, y'all, what you're going to have to write on your MyMathLab would be the solution in this case would be, well, I don't know how, honestly, I don't know how it wants the answer. I forgot. There's different ways you hear faculty say it. One will be infinitely many solutions. One would be all real numbers. I don't know how this particular software wants the answer. Basically what this means is that any value for x is a solution there. Anything works in this case. So in other words, if I just pick x is 10, just because I feel like picking 10, plug in a 10 here on this side and on this side, it's going to work fine. Let me do it for you quick. 4 times 10 is 40, 40 plus 1 is 41, 41 times 2 is 82. Let's do it on the other side. Plug in a 10. 10 plus 2 is 12. 12 times 8 is 96. 96 minus 14 is 82. So if you plug in a 10, 10 makes both sides equal. So 10 is a solution. But you know what? X equals 9 is also a solution. If you plug it in, it's going to make both sides equal. If you plug in a 15 or a negative 100 or a negative 1005 or a negative 5.2, any value for x will make both sides equal. How do you recognize that? If you ever notice that your variables disappear from the equation, like happened here, but you're left with a true statement, you're left with two equal amounts, that is telling you that whatever value you use for x will always produce an equal amount. The x is irrelevant. It's not going to matter. You're always going to get the same amount on both sides. So in this case, it's one of these answers. I'm not sure which one. You'll see it when you log into MyMathLab. For me, you can just write the answer to this is infinitely many solutions, all real numbers, any value for x, something that shows me you understand. Now let's do the second one so you can see this other exception, this other rare thing that comes up. First we're going to do is combine like terms there. 7x plus 2x is 9x minus 5 equals, I'm going to distribute here. That's 9x, 3 times 3x is 9x, 3 times 2 is 6. So 9x minus 5 equals 9x minus 6. Think about it. 9 times the number minus 5 needs to be the same as 9 times the number minus 6. Right there, something should be fishy in your mind. How can 9 times the number minus 5 be the same as 9 times the same number minus 6? Well, let's keep this going. If I try to move my x's to the same side to combine them, once again we notice the x's completely disappear from the equation. So write down what's left. A negative 5 and a negative 6. Unlike the previous problem where we concluded that this was true always, this is false always. What I mean by that, negative 5 is never going to equal to negative 6. They're just two different amounts. This is not true. This is false. What does that tell you about the answer? Well, the answer you would write on my math lab or on my paper would be, instead of saying there's infinitely many solutions, you're actually going to say there's no solution to this problem. It's impossible to solve. There is no value of x that will make this side identical to this side or equal to this side. It's impossible. How do you recognize it? Whenever your variables disappear and you're left with something that's not the same on each side, that's telling you that it doesn't matter what value you use for x, we're never going to get the two sides to be the same. As opposed to this one, the x's disappear, but we have the same thing on both sides. That's implying that it doesn't matter what you use for x, you're always going to have the same thing on both sides.